Thank you so much. All right, sorry for that, everyone. Thank you so much for joining today's talk, Data Visualization and Accessibility. And first of all, thank you for everyone who has played a role in this conference, everyone who participates, and everybody who volunteers for it. I truly appreciate it. It's one of the most valuable conferences for me, and I think just all the people here are salt of the earth people. And it's out of all the conferences I go to, is really really the best. So, all right. So this is a presentation I've been giving variations of since 2022, and I'll get a little bit more of that into that later. But this year I've added something new and cool. It's a GPT that kind of jumps to solving the problem that we'll be talking about. So that is just to start off there. I usually put this slide at the end, but I wanted to put this at the beginning and the end so I don't miss opportunities to connect with folks. So on the left, you see is my QR codes for my LinkedIn. And on the right is the Plot Grio, that is the bot that I'll be talking about later. And that you can jump right in and use that. And then just a quick plug here. The Design Psychologist podcast will be dropping in about a month or so. That so far just the trailers up there, but episodes will be coming. So check that out. All right. So for today's agenda, we're going to start off. I'm going to tell a quick story to frame what we're going to be talking about here. And then I want us to spend some time really appreciating the problem that we're going to be solving. I don't want to just jump to, here's graphs and then here's things that you should do. I want us to take a step back and look at it, the problem, and appreciate it. Then I'm going to propose a framework to help orient our thinking for how would we come up with a solution to the problem. And then I'm going to dive into what I'm submitting is the solution. A little girl, when she was 6 years old, was diagnosed with macular degeneration and cone rod dystrophy. And specialists told her that she was going to go blind. And they told her mother that they might as well not invest in her education. She was interested in science, that it would be pointless and it would be a waste of money to do that. And her mother did not listen to that and paid for her education anyway. She ends up getting a degree in biology. Is it biology? She ends up getting a degree in chemistry and then a PhD in chemistry. And today is the professor of bioengineering at Northwestern University in Massachusetts. And what she's doing today as a blind professor teaching sighted students is she is currently leading a charge to use tactile graphics to have a common graphic that both blind people and sighted people can get information from. And it's a method invented by Brian Shaw of Baylor University, or who came up with the idea. But she's using and implementing this in her classes to create graphics that you can both feel and see. And so we'll return to that in a little bit. But I open up with that story to kind of frame the goal of what we're trying to do here, is that accessibility is, we think of it as it's inclusion, and it is, but it's also the smart thing to do and the humane thing to do because you're including brilliant minds from everywhere. So if I make data visualizations that Mona Mankara is her name, can't use, then I'm losing out because she's a biochemist and I'm not able to get things. So we want everyone to have a flow of access of insights is really the motivation behind data visualization. It's not just that we're being nice, it's that we need to have everything be as accessible as possible. So let's think about the current state of data visualization. Data visualization as it is already unusable and already usually pretty bad. So before you even talk about accessibility, it's riddled with problems. Right now, for folks who aren't seeing the slide, I have a fancy dashboard that's moving all around. And essentially, we do things where data is hard to read. It's hard, it's not being communicated very well. that's before you start talking about accessibility. So it's not accessible to sighted people either half the time. So so that's most things, dealing with dashboards and data visualizations. That's a whole area, and we're not gonna, this is beyond the scope of today's talk, but that's touching on that. There's things that you want to keep in mind when you're picking a certain graph, a bar graph versus a line versus a dot plot or a scatter plot, or a box, a box plot, candlesticks, and everything else. So here's an example of a dashboard as experienced by someone using a screen reader. I think my sound is hooked up, so I'll play this. So if I'm using a screen reader and I something like, okay, we can't hear it here, and if I turn it up here, then we'll get the feedback. All right.
And then I can decide, once I pick which component I want to explore further, I can just hit enter.
Product Amarilla. Sales 17,747,116.06, 14.95%.
And now I can tab between each of the individual data points to hear the data behind each slice of the donut.
Product Carretera. Sales 13,815,307.89, 11.64%.
So I'll stop it there. And what we noticed, do you want me to click unmute or, okay, unmute or late? Just close it. All right, I'll say later. Hopefully, I hope that doesn't mess anything up. Okay, it's a dialogue. Okay, so what we see there is we've got a data visualization that's meant to give us a whole bunch of information in parallel somehow. And what is the screen reader doing? It's reading the individual values, effectively rendering it the same as a table. Okay, so that's something to think about, right? And we'll come back to that theme. Data sonification, in terms of other things that people are folks are playing around with as ways of transmitting data through different modalities. Here's a couple of examples of data sonification. So this first one is a simple visualization in high charts, has features around this. So turning data into sound. Where's the play button for this? Here it is. And I'm told that there's, I haven't played around with them yet, but sonification features on iOS and other platforms. You know, so that is one proposal for how to transmit data insights to people who are blind and seeing impaired. Here's another example. This one is a audio rendering of earthquake data, and this comes from Oklahoma earthquakes. So let's listen to this. So any comments or questions from anyone on this? Any ideas or comments about this? I have my ideas. I don't know what, I always am curious to see what folks think about this. Yeah.
gives you an idea of what's happening, but, and maybe the graphic up there I don't get where 0 to 10 is. Is that 0 to 3? Is that 0 to 20? How far is that scale?
Right. Right. Yeah. So having an idea of magnitude of things, like I hear sounds and it sounds kind of loud, but I'm not really getting a sense of scale. Any other thoughts on that? So yeah, I mean, I think my thoughts on this are kind of when you talk about standardizing this training, I think there's probably some promise to it. There are astronomers who have used technology for the extremely multivariate data that they're kind of involved with all the time. So there's ways of thinking about how do you take rich data and transmit this to people's brains. And there's certainly ways of doing it, but one of the problems that we think about is scalability. So it's one thing if you're maybe a specialized scientist and you're learning to use a tool and you're getting specific insights that you can make decisions based on, maybe there's some promise there. But when we're talking about finding a tool that we can scale, would something like this become as popular as Braille? Who knows? But that's something to think about. This next thing is lithophanes. So that's the story I opened up with. These come from a method or a technique that is at least 1,000 years old, and it comes from carving porcelain. You take a thin piece of material that light can shine through, and by having different heights and in the gradient, you can feel things. So on the screen for folks who aren't seeing it, we have lithophane objects. We have one with a lion on it, one with Star Wars scenes, and some with graphs. And then we've got some more images of lithophanes that you could see as people are holding up things to the light. And this is Professor Mona Mankara, the professor who I opened up the presentation with. She is using lithophanes in her classes using glue guns, where she has sighted students trace graphics with glue guns, and they 3D print other graphics. So this is sort of a frontier that's being explored regarding how do you take data and make it accessible to all. So in thinking about this topic, there's a whole bunch of different factors that are beyond the scope of getting what we're going to get into today. For people who aren't seeing the screen, we can think of things in terms of the bits of information and signal detection theory. How do we make sure that we're sensitive enough to pick up data? We'll get into a few of these things later. So accessibility, huge area. Data visualization, huge area. We're talking about that at the beginning of this class before we started. So for here, what kind of framework do we want to deal with in terms of just wrapping our minds around this and before we jump into the solution? Well, first, insights are the name of the game. When we think about it, all we're trying to do with data visualization is get insights to a human brain. There's data, and then how does my brain get insights from the data? Visualization is there because we're leveraging something that humans, sighted humans, are naturally good at. We can see shapes and we can judge things in the environment. We get a lot of neural architecture for free, a huge amount of our occipital lobe, right? The part of the brain in the back, a lot of cortical area dedicated to seeing things. So when you can leverage that to view data, we are able to just look at a graph and see the shape of it. And then therefore we can get hundreds of data points simultaneously and be able to get those insights. So that's really the purpose of what we're trying to do. So we want to take a couple of steps back and just look at the fact that we're trying to get insights. And the framework I also want to think about from the other end is that data visualization could be described as a form of accessibility. If you think about the fact that humans are bad at perceiving tables of data, right? So if you're looking at just a big data table, the ability to detect patterns and something like that, we're horrible at that. So we need the accessibility, it's on the sighted end, just to make it something that you can see patterns in, right? So you're encoding data into patterns. You're starting from raw data and encoding that into patterns. So to show this framework for folks who aren't seeing it, we're going from left to right, from raw data, and we're marching the raw data to more and more organized and more perceptible. So raw data up to organized data to visualized data, but ultimately you're trying to get to the insight, right? You're trying to deliver insights from the data to people, to the human brain. And for folks who aren't seeing this graphic, I have from bottom to top what I'm calling layers of facilitation. So on the bottom level, let's just try to get regular data visualization right. Follow good practices for that. And then the layers of accessibility, kind of you're layering that on top as you're making things better and better. Okay. So just a little bit of history. For folks who aren't seeing it, we've got a horizontal line going across the screen that represents ideal or perfect. And then we've got over the course of history swooping in toward better and better. So data visualization, you look at the history of it, statisticians who are trying to solve problems in agriculture and various forms of science come up with ways of processing the data that they're using. This gets better and better. The key here is that it's way better in theory than it is in practice. We have books that have written in the 1980s by Edward Tufte, in the 2000s by Stephen Few, greatest data visualization practitioner ever, I would say. And so much has been documented on this stuff. It's just we're not always following it. We'll talk about some of those reasons why, but there's a lot there that we can work with. And then we have UX, human factors, and I think related to that, accessibility. Beginning at, back World War II, trying to make machines more usable in the military. And over time, this kind of comes into the world of computing, and then eventually the web and mobile devices. This is stuff that improves over time. So there's a lot of reason to be optimistic about this stuff. Here's just a quote from Jacob Nielsen as recently as 2012 about mobile usability. To read just the highlighted parts, what should we make of the huge difference in conversion rates between desktop and mobile phones? We're talking about how mobile usability back then was so bad. The mobile user experience must be horrible, or it's not worth investing in mobile design. And this just shows how, even as recently in 2012, it was known to be just very rare for there to be, if you remember browsing the web back in the day and you had to like pinch and zoom into websites because it wasn't standardized yet. So when we increase the accessibility, everything improves. Part of the reason why mobile design is so wonderful is because so much effort was put into accessibility. There's so many technologies out there that everyone uses every day, that seeking accessibility is a large reason why it was good in the first place. And so I love the example of the ramp on a sidewalk. Everyone benefits from this, right? It was designed for wheelchair access, but guess what? If you're a parent with a stroller, it kind of helps. If you're just a person shopping and you've got, you're rolling a cart, or you're just walking and you just don't want to step over the thing and you just kind of angle yourself so you walk up the ramp, it improves everything for everyone. So maybe it's the case that accessibility can fix data visualization. So the two fields can probably inform each other. Okay, let's get into this framework, signal detection theory, or signal and noise. I find this to be a useful way of thinking about and having a common language for data visualization and accessibility. So if we say, okay, data, I'm trying to get insights from data. It's information, right? It's bits of information. Information's measured in bits, right? So just like length is measured in centimeters, volume is measured in liters, information's measured in bits. So when we're talking about how do we transmit bits in an efficient way, and a lot of them, as many as can help support an insight for me, how do we get those bits to human minds. One of the things we want to think about is we want to reduce or eliminate the less relevant ones, right? So there's lots of bits of information. If something's not relevant, you want to mute that as much as possible. If something is relevant, that's a signal. So you want to boost that. You want to make it as signal-like as possible. When we're just talking about just the raw science of what's happening when we're doing data visualization or anything else. And signal detection theory has been a useful framework for thinking about this. It relates to anything from, in the military where you'd have people trying to see, officers trying to see incoming planes or submarines, and there's a staticky display. You want to have a big difference between what's an actual submarine versus what's a fish or something like that, right? And so you have this framework. For folks not seeing the slide, we have a column detected and not detected. So that's talking about what the person is doing. They detected something or they did not detect something. Then the rows going across, we've got there was a signal present or there was not a signal, right? So then we get a quadrant. If you detected something and there really was a signal, that's called a hit. Means there's something really there. Yes, I got a hit. I've got the thing that I was supposed to see. If there was a signal there, but you didn't detect it, that means you missed it, right? So that's known as a miss. Then now we go down to the no signal. If there was no signal, but I said, yes, there's something there, that's a false alarm. And if there's no signal and I didn't see anything, that was a correct rejection. So when we take this and we think of it in terms of data visualization, the hit is what you want. You've got a piece of actual information, you want people to see it. If there is information but people can't see it because you picked the wrong visualization, say a pie graph with 30 slices, there's going to be all kinds of things in there that just you can't see, despite the fact that it's a data visualization. It's not doing its job of transmitting data to your brain. Let's look at what if you have detected something and there's no signal. Think of a situation where we wanted to decorate a dashboard, right? Your boss said, I want this dashboard to be really colorful, sexy, right? I want it to be exciting. And so you add all kinds of factors, visual factors that don't map onto data, right? So in data visualization, you want variation in something visual maps onto something that's varying in terms of the data. But if I'm just coloring things in for the fun of it and decorating things, I'm creating lots of opportunities for false alarms. My visual field, visual load, I have to search around to be able to find things. By the way, the experience of looking at a beautiful dashboard and enjoying that's just a very firsthand sort of instant, maybe emotional experience, more suitable for a demo, right? So if you're presenting to executives who aren't going to be the ones using the dashboard and you just want to get them excited, then maybe you could justify, I still wouldn't show them that, but maybe you could justify doing that. But if someone has to sit in front of this dashboard every day and you've made something that's you think is beautiful, but they've got to sift through it to make decisions, that's not where we want to be. And we want something where there's no signal for there to be nothing detected. So this is signal versus noise, where noise is something that looks kind of like a signal, and you might think it's a signal and have a false alarm. So you want that ratio of signal to noise to be as high as possible. In signal detection theory, it's known as D prime, if you're interested in looking into that. So that's kind of the overall framework. How do we transmit data to people, leverage what we're naturally good at, and do it in a way that people can get insights? Now, again, going back to these common examples, looking at an example like this, this slide is showing colorful graphics. You've got a donut chart where There are many different variations of the same color, the same hue, so you can't really see the different categories in this continuous range of rainbows. Anyone have want to comment on this? It's late in the day, and I've noticed it's a little bit of a quiet group today. So you say what? Yeah, like yeah, so color blindness. This is going to be a nightmare, right? Oh, absolutely. Anything else? And it's noisy, therefore, and you have to do a lot of visual work to see anything. How about the curvy lines? Because curvy lines are more pleasant. Study shows they're slightly more pleasant. But when you ask people to, if you want to curve the lines to make it look good, what's happening here? You know, you're actually the best guess as to the shape of, if all I know is this piece of data and that piece of data, what's the best guess between the two pieces of data? The best interpolation? It's a straight line, right? That's the best. So, but if you're curving it because you want it to look good, so then this one curves up because it knows it's about to go down, but you don't know that it might have curved in. So you're literally in this case making up data to add some kind of aesthetic appeal. Here's another example of a data visualization. Folks who know me well, I never miss an opportunity to diss Microsoft. This is Power BI. So if you ever need examples of bad data visualizations, go to Google Images and type in Power BI. So, you know, here, there's just a lot of entertaining stuff going on. If you don't have to read the data and you just want to kind of look at this, it's visually appealing, right? You've got this chord graph. I've never met anyone who really knows how to read one of these things, but they do look cool, right? But if we're talking about transmitting information from one human mind to another, this is not going to be the most efficient way to do it. It's very noisy and it's not capitalizing on the strength of our visual system. Here's another one with just a very overloaded display of dots with lots of colors that just, if you want to get insights from this, this is probably not the way to go. Here's another one that looks very cool. Again, if I don't have to use that, I actually find that pretty cool looking. But if I have to make decisions based on this every day, or God forbid, if people's human lives depend on this, maybe if I have to, you know, keep fast trains from running into walls, or, you know, whatever it is, you want to deliver insights to people. Not enough signal to noise difference, and too much visual noise. Okay, so a lot of these things are problematic that we've talked about. The visualizations, the normal state of affair for data visualization is problematic. There's a lot of things I would recommend if this is something you want to get good at. The first things I would recommend would be Stephen Few, in particular, information dashboard design. Yeah.
Triggered you about Stephen Few.
Oh, what's the Stephen Few story?
He said, let me state my basic premise. A dashboard, Stephen Few once said, let me state my basic premise. A dashboard that is accessible to blind people is not a dashboard, is a contradiction in terms, is what he said.
Did he say that?
Yeah, he said that.
It is inaccessible. He said inaccessible.
No,
Is accessible?
A data data dashboard that is accessible to one user is a contradiction in terms.
I would need more context around. Yeah, please do. I do love Stephen Few, so I don't want. I guess this goes to the don't meet your heroes.
Yeah.
So visualizations, they're already largely problematic. With the screen reading of the data visualizations, we saw that was problematic as well, because they are just reading data points. At that point in time, you're just checking the box of it can read. Now, there are situations where you do want to read, or like a lookup table. If you need to know, like, okay, give me the numbers for February sales, and it just reading that. So there are cases where that is appropriate, but there's a huge, probably majority of the time in data visualizations where you probably want something more. Sonification, very cool stuff, probably usable. There's been a lot of psychology and neuroscience studies where you can give people extra senses, you can give people the ability to gain information about the world through extra senses, but the scalability would be the question. If we are dealing with having a product or having a website, how do I make sure thousands of people out there who need to get this are able to? Tactile graphics, another thing, very, very cool. We should pursue it all the way. Perhaps there could be some way in the future of having something that's similar to what a Braille keyboard does, and maybe it dynamically raises and can show things. Maybe something like that could be something. As it stands now, maybe not the most biggest opportunity for scaling to lots of people. Okay, so what are we going to do then? So ultimately, what we're trying to do again is we're trying to get the insights to the human mind. We've been talking about data visualization. We're using that because we're leveraging the visual system, the ability for us to automatically see colors and to see direction and shapes and sizes. We are coding the automatic neural circuitry of all of that, coding the data in a way that you can put on a display, and you can very rapidly, pretty attentively in some cases, be able to get a huge amount of insights. So that's the number one thing. Visual system, the strongest sense, insighted people. We've been doing that for millennia, drawing pictures. But we've also been storytelling. And it turns out that storytelling is also leverages certain aspects of the human mind. We are able to understand and remember things more when we hear it in a story form. It gives us the sort of mental shelf space to where we can mentally put facts in the right place because there's a story framework around it. There's a lot of interesting research around that and the ability of storytelling to make things better. So I'm going to leapfrog here from storytelling. So we've got the visual system, leveraging that as one strength, and then storytelling. This brings us to a solution that's based on captions and alt text. This might be sort of anticlimactic, but you know, when we think about it, there's just a lot of merits here. So to talk about the you know, so just high level, you know, screen reader, a lot of talks here about screen readers that get into the details of things, but some things to think about. If you're doing screen reader for a dashboard, you want a good hierarchy. So things like the dashboard title, the title of the individual different views, right? So if you have the different squares on the screen and they're showing different data, the ability to quickly and broadly and horizontally kind of jump around for the screen reader user and say, okay, what is this screen? All right, what's on this screen? I see there's like 4 different modules. And then going into the later layers, like filters, parameters, legends, and so on. And so here are some technical considerations of the solution that I'm about to talk about, where we describe the visualization. So alt text, yes, good for short things, but there are other techniques you want to use from a technical perspective to put the big block of text that I'm about to show you that would be necessary into the screen. So the big block of text just shoved into alt text isn't going to work. That's not going to scale. But there's ways of doing that if you have it as a figure element in the HTML, and you know, it's able to detect that the fig caption and so on, and it is able to be at the right level of hierarchy, and you're going to read a long set of verbiage. And here's just a quick example of the structure that we're talking about here. So why captions? It avoids some of the pitfalls of the other solutions, the solutions that are very, very cool, and maybe in the future we'll be able to have them be scalable. But for now, is what we have today working? If a screen reader is just reading bullet points, again, it might as well be a table, and tables are what we are not trying to have, and so on. And then the existing skill set of of reading can be applied to this approach. So what we're talking about here is a method for writing captions or writing descriptions of these graphs. And some overall methods, approaches to this is, first of all, why are we describing the graph? Because it's might be the closest you can get to parallel if you're serializing the data. So in other words, if I'm cited and I'm looking at a data visualization, I can see a curvy line that is trending upward. That's a lot of data for me to, in parallel, simultaneously at once get. I can see the shape of the line, and the line has whatever number of data points in it. Whereas if I'm listening to a reader, it's serialized. I can only hear one word at a time. But if we can describe the data, we can raise the level that someone is interpreting this. They don't need to hear the serial readout of numbers and then say like, okay, I guess the numbers are going up, and then did they go back down, and then they kind of went back up, sort of. And then you've got the working memory demand of trying to remember all that, and it's really untenable. So what we're going to do is talk about how do you turn that into text with a bias on clarity, all right? And this method is based on that. It's being as clear as possible. Think similar to if you're a journalist writing a news story. There's a certain order that you're supposed to say certain facts when you're writing to inform, starting with the important stuff. You have to think that if it's a long paragraph, there's going to be drop off the further down you get. If 100 people are exposed to this long paragraph, the most people are going to hear the first part, and you're going to get fewer and fewer as the paragraph goes on. So you want to get the important stuff at the beginning. You want to engage in good summarization, right? You want to do a good job summarizing what's happening, because it's ultimately what people will walk away with. So how can we summarize the data similar to how the data visualizations do? And redundancy on things only when necessary. Okay. I'm going to just touch on this point. I don't want to get lost in this point here, but there's a couple of different directions you could go. You could say, I want to describe this data visualization as good as possible. Or you can say, I want to deliver the core insight as good as possible. And so that's a tricky one. But ultimately, the data visualization's a means to an end. So for example, if you say that, maybe it's a distribution and the mean in the middle, or the middle somewhere around 80. Let's say that's not called out in the data visualization for sighted people, but maybe you'd want to mention it because saying that would help someone using the screen reader to understand it better. So what are the core important things about this set of data, and how can I transmit that as insights to the human mind? Okay, we're going to walk through some examples. Now, this is the framework where we've got the full text of this this bar chart, and there's an anatomy to this paragraph to the right. So for people not seeing this, there's a bar chart on the left, and there's a paragraph on the right. Then I'm going to march down the different parts of this paragraph to show you the anatomy of it, so we can get an idea on it. By the way, this is still largely an untested sort of approach. So I invite academics and folks, anyone involved in doing research, test this stuff. Let's all improve it together, and let's figure out what tends to work the best. So this starting off with the graph title. Just what is this thing? Just properly orienting people. February jobs 1 month net change. That's the thing we're looking at. Is a bar graph. Okay, great. Now I know, like, I have the basics so far. Ranking industries on job creation. So we've got a lot of sort of parallel insights here, right? It's now I know that the length of the bars is going in order, that there's some rhyme and reason to this. It's not something that if a screen reader, I wouldn't have known until I get to the end that it's ranking. So, or maybe I might pick it up by the middle, but let's do that. February jobs 1 month net charge is a bar graph ranking industries on job creation. Industries with the highest numbers of job creation are at the bottom, are at the top. The lowest are at the bottom, right? So now we've got this really good orientation. Now you can stop there and you kind of know what the graph is. Compare that to saying February jobs, 1 month net change, 179K, 95,000, 94,000, right? This is much more, clear. From highest to lowest, values are as follows. Now you can get into the specific numbers. For someone who's digesting this chart, they could flip to the next one if they've had enough. Oh, I get an idea. I don't need to get the numbers. Or they could stick around for that if they need to answer specific questions based upon the details, because that's later. So they start off with the understanding, and then we get to the other stuff later. Okay, so let's take a look at this one. Rising college costs, that's the name of the graph, is a time series line graph. All right, so that's what type of graph it is. Okay. That shows the cost of college rising over time. Okay, great. We've got a whole lot delivered just in the first few sentences. The graph compares 3 types of college from the years 97 to 2020. So this is where things get tricky and a little bit subjective. But this gives us the ability to talk about the trend. So that's the orientation of the display. What are we doing here? We're properly orienting people's minds about, okay, like what's actually going on here? Okay, there's three types of colleges being compared, and I've got the range, 1970 to 2020. The 3 types of colleges are private nonprofit 4-year colleges, public 4-year colleges, and public 2-year colleges. That's the data clarification. That's a so this is kind of like an optional thing, a data clarification. If there's something that would be otherwise kind of easy to miss, like someone, you might not get it. Here's number 2. The tuition amount is shown on the y-axis. To be precise, it is the average amount that a student would pay in tuition and fees adjusted for inflation. So that's a better example actually of something that you could easily miss or not understand, or fast forwarding. Okay, the data are in 2019 dollars. Here are trends, blah, 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 right? And so then it shows and it discusses things at a trend level, and either saves the data readout for later or maybe forgoes the data readout, depending on what's important. Let's do a final example here before we get into the GPT solution. Corporate tax rates around the world 2020 is a choropleth map, or heat map of a world map. Now, choropleth is an unusual word. Perhaps you could just say a heat map, but I don't like saying heat map. It's just, but use your discretion there. The visualization illustrates the corporate tax rate of each country in the world. High rates are displayed in a reddish tone, while low rates are displayed in a bluish tone. Dark saturated colors represent extreme values, while lighter colors closer to white represent moderate values. From left to right, this map can be summarized with the following characteristics. And I won't read all of that, but this goes through then summarizing things the way a person would kind of see it. They say like, oh, well, it looks like Russia and Europe and sort of the Middle East is largely in blue. Okay, so that's pretty good. And then, but it looks like South Africa is largely in the red, and then everything else is sort of pink, right? That's the way we would, if you're sighted, you would see this much more in parallel. There's a lot more parallel information going in. So when we're dealing with this serialized modality of reading it out, how do we still deliver as much of that parallelism as possible? Okay, so to take a look at this GPT we have here, PlotGrio. So I configured this over the weekend, so you have to bear with me. We're gonna load a chart into here for an example. This is live. We're doing this just random. So I'm gonna just say Tableau chart. This is going to give unlabeled charts. I really don't want, I want like a real chart that shows real data. Sorry, I should have had this set up, but let's do this sort of this one. No. Let's say news or something. Maybe it's taking like real data. Oh boy. Bear with me, folks. I will find something soon. Is this a good one? What's this? I guess we can take this. This is a simple one. I was hoping for something a little bit more. Save image. Okay. So let's try dragging this. So we're going to drag this into this little bot I configured, and let's see what it does. Okay, dashboard titled Dashboard 2 combines a horizontal bar graph and a geographic bubble map to analyze wildfire strikes reported in aviation incidents. The top chart, sheet 3 displays. Okay, so you see that it's kind of describing these things. Now, just sort of a fun story with this. When I first proposed this idea, it was in this time of year, May 2022. So that was right before ChatGPT came out. And then so when I talked about it the next year and through that winter, a lot of people started getting curious about this. This is kind of like a weird approach at first because the technology wasn't there. But the technology got there, and there was a bunch of folks kind of working on different ways of trying to kind of achieve this, but it was still difficult because LLMs weren't really that sophisticated yet. But now ChatGPT is good enough where it had a good enough baseline to where I could train it on my previous slides from this presentation and some other commentary about the anatomy of the paragraphs, and it was able to come rather close. So this is just out there. I just put this on. I put this on the thing. If you search ChatGrio, you should be able to find it. It's free. And I think the proposal here is to play around with the idea of, can we find ways of leveraging this kind of stuff where we can use this for, you could putting it on your website using a tool like this, or dynamically do it through APIs, right? So you could tell your product, when there's a chart here, pass it through this API, send back the text, and then now you can put it right into this object description. Can this be a way that we can leapfrog past a lot of pain in the short term when we're trying to solve this as a problem? And this is ultimately dealing with the idea that we're trying to get insights to the human mind so that we can all benefit from people's ability to use data. So I'll stop there. Thank you very much. I don't know if we wanted to jump into questions or.
As you mentioned, like people who are using assistive technology, they just need to know the overview about the graph, right? If there's a graph complex thing, I just need to know what's going on. if I'm going to present this approach in my organization to business people, it will backfire to me. They will say, if this is they want to know, you can do this with the table. Why we need to invest design effort and development effort on these graphs to make them accessible. So how we can sell this in organization?
Yeah, so, okay, so are you saying that people in a high-ranking people in a corporation will hear, hey, all we have to do is well, I personally think that this is an approach that maybe the design team and the research team work on. And I don't know. Yeah, so the automated thing would be a hard one because that requires, it's a dynamic solution. And, you know, because there's one level of solving the problem where the design and research teams can generate this, and who knows how you generated it. You could generate it however you want. But if you're saying to your organization, hey, we don't need to do this, that might be something that has to be navigated.
This is a funny idea that came from this presentation. Before that, the less expensive approach that we are taking is like we are developing two type of UIs. One is fancy graphs and everything. If you want to turn it to accessible, you press some button or turn this accessible, it will turn into a simple table where you can leave the information.
But that's not accessible.
That's, yeah.
Yeah, right? Because, do you want to speak on that?
You already spoke. to it.
Sorry, you're making me run around the. Yeah. So yeah.
You already spoke to it. You said, like, look, we don't use data visualizations because they're pretty. We use them because they provide insights, right? I want to know, like, if you show me a data table, am I going to be able to tell that the shape of the data is like this, right? That's what we have a visualization for, right? And an equivalent experience is where the blind person also knows that the data goes with it like this without having to step through it. You need to have it's the whole to part to whole problem, right? That's what you were describing, is you give them the whole, and then if they want to dig into the data and listen to the individual, they can build up the parts, but don't make them take the parts and build up the whole. So it's not an equivalent experience. I can't speak to the business aspect of what you're saying, like if they're making that decision, well, okay, you can pass WCAG by just giving them a data table, but that's because WCAG doesn't say anything about data visualizations.
Right, so if the argument coming from the, thank you for, if the argument coming from the executives is tables, I mean, I would make exactly that argument that we're defeating the purpose of data visualization if we're gonna render it all to tables. And then I think that would probably be an opportunity to give like an internal presentation in the organization, talking about, hey, this is why we have data visualization, you know, and
How many people are we excluding?
that's right.
How many paying customers are we excluding by not giving us enough information?
Yeah, for those who didn't hear that in the back, how many people are you excluding? And if you want to translate that in the language of capitalism, you're saying, look, these are paying customers, you're not making money. It was, oh no, we've got to fix this now.
I think it all gets down to purpose of elements on a page. A table can portray information much better than something else, but a data visualization, I mean, it gets back to a picture's worth 1,000 words, kind of thing. You can communicate a whole lot better and a whole lot more richly than you can in a data table. So I wanted to comment on that, but the other thing was, I'm really interested as a novice in AI about how you constructed that.
Oh yeah, so absolutely. So so yes, as for how to construct something like this, if you have an account with ChatGPT, I haven't explored this capability with some of the other ones like Claude. I know this is going to be probably something that they all can do by the end of the year. But in ChatGPT now, you can now go into, you can explore GPTs. So you say, explore GPTs, all right? And then it gives you sort of this marketplace of GPTs that different companies have created. And you can, and basically what they are is all of them are Chat GPT, but it's as if you gave it perfect prompts for what you want it to do. That's essentially the way to do it. So if it's, if you say, hey, I want a GPT for writing grant proposals, right? And then somebody who's an expert has already thought about that, and then you download that, you use that GPT, and then you say, hey, I'm trying to write an exam, and then it knows whatever questions to ask you or knows how to fill it in. So once you're on Explore GPTs, you go up the upper right-hand corner, My GPTs, and then it's got the option to create some GPTs. And you see this one, Plot Griot, that I've put here, that I've described today. So yes, it allows you to put your own configured GPTs.
So in terms of getting some of these down, and is there any way to look underneath the hood to see how the
Yeah, so I don't know what other folks can view. When you make one yourself, you're able to view its configuration. You can name it, describe it, and then there's like another tab where you can configure it. In terms of detailed under the hood, because instructions. So this is configure. Oh, that is configure. Then create. Oh yeah, it seems like a little bit opaque, honestly. And so yeah, the proposal here is anyone can do this. This one I've constructed based upon this stuff outlined in this presentation, but you can imagine this just being generalized as an approach, right? You might have a different purpose for how you want people to use data. You might be trying to optimize for something slightly different and then make your own. But this is available if you search Plot Griot. You can use this. What else? Other questions?
I noticed in the, I noticed in the captions that you provided, there were things that were like, I guess, purely visual information, like in the bar chart, that it goes from top to bottom. It is important that it's in order, but I wondered if you saw that as important when it comes to having a parallel experience.
Yeah, I'm still chewing on that one. And I waver back and forth even from graph to graph, like how much emphasis I'll put on the visual side versus just describing the data. And it's tricky. I'd love to hear if someone were to study this, what would be the differences? I try to just sort of on an intuitive level, I try to strike a balance between I don't want to describe things so much that it's distracting, but and then on the flip side, I don't want to leave them out. I don't want to leave people out of the experience. So it has colors because so like let's say like the map, the colorful map. I don't know if you necessarily need to talk about blue and red. And then what if it's someone using a screen reader who's not blind or knows what blue and red is versus someone who blue and red isn't a meaningful thing. So yeah, that's something to chew on. I'd love to see how that idea could be kind of ran with and developed.
It's for them.
Well, it's for this. Yes, it's not that you're not loud enough. It's the
Chart sonification high charts.
yes.
So do you have any recommendation? These are the libraries that we can find.
Certain data discovery tools are now offering that as a feature, sonification, to where it like plays the chart. I've played around with it a little bit, but I'm not ever able to get really much of a handle on how much standardization there is on things. Like, so when you think about like the earthquake one, And I think that might have been before you walked in. The earthquake one, it had not only highs and lows, but it had different instruments, right? Like some things were more like chimes and then other things. So what does that all mean? I think you'd have to train someone a lot to really be able to get that rich data. And if that's the case, then I think it could be promising for specialized things. Like if you're an astrophysicist and you're observing the night sky and there's a massive amount of data coming in and you've been trained on an audio thing and it like scans across the sky and there's a certain way it does it and you've but you know that kind of thing, in order to get good at anything you need a feedback loop, right? That's what people need to get trained. So you need to say like, yep, that's close, but nope, that was wrong. And then you get it after a certain amount of time, which is, you know, kind of leads me to the conclusion of the scalability problem of how would you get to the point where just news articles could have sonification to display data and, you know, you're able to do it that way.
You know, of any research results that are out there, like the history and how or why some of the news that.
I mean, I haven't looked deeply into the research on that, on the effectiveness of it, on the how and why. I think it's just the I suspect that some of it's technology push, that it's cool, and so people build it. I think some of it's that because it is cool. You can imagine being in a high charts demo and like, now we can do sonification, right? You know, but you know, just the moving the technology forward of how can we take data beyond sight? Yeah.
I can tell you that there are no standards about it. I've looked extensively
Okay.
at sonification and first off, I used to work for W3C, which is what standards are.
Oh, okay.
And I can definitely tell you there's no standards around, there's no web standards around sonification. But I can also tell you from having been in the sonification community a bit, that there's no agreed upon, I'm gonna say auditory vocabulary. Right?
Yes.
That,
Good way of
So-
Could you inform us about some of, in the sonification community, some of the different either camps or different competing ideas?
Okay, so if you're really interested, there's something called sonification handbook, which is a little dated now.
Okay.
I would also look at what they're doing at Georgia Tech, because they have a sonification lab there. Bruce, his last name is escaping me. But they're doing the biggest things on sonification. They work with high charts. I know that they work with high charts.
Okay.
Do their sonification. And then there's ICAD, the International of Auditory Design. It's ICAD is the name of the society. And
It's I just looked it up. International Community
Yeah.
for Auditory Display.
Yes, and great conference, but going there, you can see there's enough, it's very experimental. There's no standards around any of this. And actually, I would argue, having read a bunch of papers about it, there's not really consensus either. So
Yeah, it might be.
it's very interesting and it's super useful.
It might be one of those things that just has to bubble under the surface and get worked on for years. VR was like that for decades. There were very few VR products, but there was a massive amount of research on VR, like a ton. Like there's a textbook VR, I forget the name of it, but it's like thick. It's like huge, thick encyclopedic book. And then VR, once the technology caught up, then it was able to go somewhere. So yeah, who knows? There might be something there. Okay, well, thank you so much, everyone, for joining, and enjoy the rest of the, oh, was there more? Okay, enjoy the rest.
Sorry.
I'm sorry, I was like ending it. I don't know if you were supposed to end it, but I jumped right in. Thank you so much.
It's done by distribution.
Oh, I'm seeing some things in the chat. 2 mics. Okay, that was the working out stuff.
Yeah.
Just a thought, not. I just wanted to say a few things. I guess I'm still on the cord. Just a thought from Elizabeth Thomas. She said, just a thought, not a question. I think you could eliminate the at least 25% of the words in the chart description and still effectively communicate the same information. I ultimately agree.